Astronomers have observed two peculiar things near the center of most galaxies. First, the stars here orbit very rapidly. Secondly, a lot of radiation is produced. Therefore, there is some kind of central engine of sorts in the center of the galaxy that is responsible for driving these two observations. As with an automobile, a massively powerful engine can give a car a lot of speed, but of course, a lot of exhaust will come out as well. That exhaust is like the radiation produced at the center of a galaxy. If the automobile had a supermassive engine, it would allow for the tires to rotate even faster and even more exhaust would come out. What astronomers find is that nuclei of a lot of galaxies contain something known as supermassive black holes, their own central engines. How they came to be and what they entail is this lesson's topic. In order for stars to orbit so rapidly near the center of a galaxy, the center of the galaxy has to have millions or billions of solar masses confined to a small space, a supermassive black hole. Another lesson revealed to you that our own galaxy, the Milky Way, has a supermassive black hole as well. A black hole is a region of space from which neither electromagnetic radiation, such as light, nor matter can escape. But because these supermassive black holes are so, well, massive, they cannot be as a result of one dead star. Instead, a supermassive black hole more than likely formed in one of two ways. It either formed when the galaxy formed as a whole, or it became humongous over time as it accumulated more and more mass as more and more matter fell into it. Meaning, either the manufacturer made the central engine pretty big to begin with, or a car fanatic supersized it with additions over time. Measurements have found that the mass of the supermassive black hole is actually related to the mass of the central bulge itself. That is to say, a galaxy that has a large central bulge will have a supermassive black hole with a large mass. Obviously, the black hole in a galaxy with a small central bulge will be smaller. Again, it's not hard to imagine this. A big semi-truck will have a much bigger engine than a golf cart. Actually, the rare galaxies that have no central bulges usually have no supermassive black holes in the center either. This means, more than likely, supermassive black holes formed as the galaxies formed themselves. However, this doesn't preclude the fact that matter does fall into the black holes. Not at all. What I mean is that the additional growth of the supermassive black hole isn't very large as a result of this. It's just like with car engines. Yes, you may add or subtract parts to them post-manufacture, but you won't radically alter their size as a result. Anyways, despite its ominous-sounding name, a supermassive black hole, when compared to the galaxy in its entirety, isn't all that huge. For instance, the black hole in the center of our galaxy has only 1/1000th of 1% of the mass of our entire galaxy. In the intro, I not only mentioned that stars near the center of the black hole orbit very rapidly, I also mentioned that they produce a lot of radiation. This radiation is like the exhaust from a car. As matter falls into a black hole, it heats up as it picks up speed, just like engines and tires heat up as they pick up speed. The reason matter falling into the black hole heats up is because it collides with other matter. Therefore, gravitational energy is converted into thermal energy. The innermost parts of the accretion disk surrounding a supermassive black hole can get so hot they emit X-rays, a form of electromagnetic radiation. By the way, the disk of matter whirling around a black hole is the accretion disk I just mentioned. In addition to the emission of X-rays, these supermassive black holes emit jets of gas and radiation into opposite directions. Scientists believe they occur as a result of powerful magnetic fields. Basically, as the gases wind their way towards the supermassive black hole, some of this gas is actually redirected by the magnetic fields and become two jets of high-speed particles. These jets are aligned perpendicularly to the accretion disk surrounding the black hole. A black hole is a region of space from which neither electromagnetic radiation, such as light, nor matter can escape. In the center of many galaxies is a supermassive black hole. In general, a galaxy that has a large central bulge will have a supermassive black hole with a large mass, and vice versa. While we believe that supermassive black holes emerged as galaxies formed, matter does fall into the black hole, but does not contribute to any major increase in size. When matter does fall into a black hole, it heats up, and X-rays, a form of electromagnetic radiation, is emitted. Before falling in, this matter whirls around the black hole in an accretion disk. Again, the disk of matter whirling around a black hole is the accretion disk. Additionally, as the gases wind towards the supermassive black hole, magnetic fields direct powerful jets of high-speed particles perpendicular to the accretion disk itself.